Hi everyone, welcome back to another video in the Web Security Academy series. In today's video, we'll be covering lab number 1 in the command injection module titled OS Command Injection Simple Case. Alright, before we continue with the video, I'm happy to announce that today's video is sponsored by hackersacademy.com. Hackers Academy is an online learning platform for individuals that are looking to become ethical hackers or security experts. It contains a ton of courses that cover a variety of topics like Wi-Fi cracking, privilege escalation for Windows and Linux, and introductory courses for how to get into pen testing. This video specifically is sponsored by the Hacking Fundamentals Bundle, which contains 2 amazing courses that teach you how to get into pen testing. The first one is the Hacking with Kali Linux course, which introduces you to the Kali Linux operating system. This was the perfect course to sponsor during the command injection module because while we're solving the labs, you'll see me run Linux system commands like whoami, ifconfig, netstat, and so on. And if you're not familiar with Linux systems, then this is a great course to take to familiarize yourself with how Linux works and how to use the command line in Linux. The second course is the Hacking for Beginners course, which teaches you all the fundamentals you need to start pen testing. This starts off with fundamentals like networking basics and goes all the way to things like scanning the network, identifying vulnerabilities, and then learning how to exploit those vulnerabilities. These courses already have over 60,000 students enrolled in them with nothing but amazing feedback. So if you're interested in enrolling in the Hacking Fundamentals bundle, use the link on the screen or in the description of the video. The bundle is valued at $97, but as a special discount for our viewers, you can get it for less than $30, which is an amazing deal, so make sure to check them out. Alright, enough about our sponsor. Let's go back to talking about command injection. If you do not have an account on the Web Security Academy, you can get one by visiting the URL portspeaker.net/websecurity and clicking on the sign up button. I already have an account and I am logged in, so to access the exercise, I'm going to click on Academy. Go down, select the learning path, go down, select command injection, go down one more time, and select OS command injection simple case. Alright, let's get started. This lab contains an OS command injection vulnerability in the product stock checker. The application executes a shell command containing user-supplied product and store IDs and returns the raw output from the command in its response. To solve the lab, execute the whoami command to determine the name of the current user. Alright, so the target goal of the exercise is to exploit an in-band command injection, and I say in-band because the raw output from the command is returned to us in the response, and in order to confirm that we exploited the command injection, we're going to execute the whoami command, which outputs the name of the user of the system. Alright, let's access the lab, and while that's loading, we'll open up Burp Community Edition, hit OK, hit next, close, and start burp. And I really need to update my burp version because I'm still running on the 2020 version. Alright, so set Foxy Proxy to send requests to burp. And now if we click on any page in the application, for example the view details page, it should be intercepted in burp, and it is. So let's set intercept to off and go to HTTP history, and from there view the requests that we're performing. Alright, let's go down and let's click on check stock, and you could see over here it's performing a post request, and if we send that to repeater and look at it from repeater, you could see that it takes in 2 parameters, the product ID and the store ID. Now, because of the description of the lab, we know that this is vulnerable to command injection. However, if you're testing a real application, what you would do is you would test each parameter for potential injection vulnerabilities. And so that's what we're going to do with the product ID field. You could see over here, it takes in a 1 and the store ID takes in a 1. Now, I'm not sure if both of them are vulnerable or maybe just one of them is vulnerable or maybe none of them are vulnerable. So we need to test it ourselves, and the way I'm going to do that is I'm going to add the AND character, which allows me to chain commands together in bash, and then I'm going to run the whoami command. Now, I might get an error over here just because of how the command is structured in the backend. However, I don't have the source code for this application, so we're going to tweak our command injection based on the response of the application. So the first thing we need to do is Control U to URL encode it, and that doesn't seem to be working for me. So copy, and then Control U to URL encode it, hit send, and let's see how the application responds. So right away, I can see over here that it's telling me I'm running into an error. So I'm trying to run the whoami command. However, I have an error on line number 5 saying it's an unbound variable. And the reason is probably that I'm running a command over here. However, it takes in other variables, and so it's ruining the command in the backend. So what we're going to do is we're just going to add a hash character which comments out the rest of the command. Let's Control U to URL encode it, and I keep clicking on Shift U, and that's why it's not doing it correctly. So Control U, hit send, and here we go. We no longer get an error because we commented out the rest of the command that was causing us the error, and we get the value of the user that is running on the system. And if you go over here, you could see that it says, congratulations, you solved the lab. Now, let's take this a step further and look at the code in the application. Now, just nature of command injection vulnerabilities, it just means that you've gained remote code execution, and so you can run whatever command you want. It's not just the whoami command. So what we're going to do is we're going to output the content of the script just to see what the script is doing. So let's remove the hash sign, hit send. And over here, it outputs the script that it's running. So let's copy that. And then instead of running the whoami command, I'm going to say cat, which outputs the content of the script, and then paste the script path over here. And then again, add the hash sign to comment out the rest of the command. And then Control U to URL encode it and hit send. And here we go. This is the content of the bash script that is vulnerable to command injection. And you could see the culprit over here. So they're using the eval command, which is used in bash in order to execute OS commands. However, they're taking in two inputs, so number 1 and number 2, which are likely the product ID and the store ID. And they're taken directly from the user input, so without any validation, which means over here that not only is the product ID vulnerable, but the store ID is vulnerable as well. And so you've got a command injection right over here. All right, so we successfully completed the exercise by exploiting the command injection in order to output the content of the user that is running on the system. Now, just like with the other lab videos, let's script the exploit. And if you're new to this channel and wondering why I'm scripting the exploit, it's because I truly believe in order to be a great pen tester, you do need to learn how to code. And I'm not saying, coding full-on applications, just learning how to script in order to write your own tools. And so I always script the exploits in my videos. So the first thing we're going to do is we're going to import the requests libraries because that's what allows us to perform HTTP requests, and then the sys library because it's going to take commands from the command line, and then we're going to import the URL lib3 library, and then we're going to use the URL lib3 library in order to disable warnings because I don't want to get warnings related to certificates. So .exceptions .insecure request warning. This looks good. And then we're going to set our proxy setting. So what this is going to do is it's going to set it to the burp proxy so that all the requests that are performed by my script get sent to the proxy first and then get sent to the application, and then any response from the application gets sent to my proxy first and then to my script. And this allows me to debug any errors that I made in the script in case my script is not working the way I intended for it to work. So let's say HTTP 127.0.0.1 and then running on port 8080. And we'll set this to HTTPS 127.0.0.1 and again running on port 8080. So let's click on view and toggle word wrap so that we could see the entire thing on the screen. All right, this looks good. Next, we're going to say if name is equal to main then run the main method, and we're going to implement the main method right over here. So main, and we're going to say if the length of the arguments that are given to the script is not equal to 3, then I want you to print the instructions of how to run the script. So this is, instead of outputting an error, what you're going to do is you're going to output the usage instructions and the example of how to run the code. And this just makes it much cleaner than outputting the error. So usage is the name of the script, and it takes in the URL and the command, and we'll give it the name of the script, which is the 0 argument. Okay, and I made a mistake right over here. This all should be within the brackets. All right, next we're going to output the example instructions. So let's say www.example.com, and the command that I want to run is whoami, and again the name of the script. And then terminate the program because it ran incorrectly. All right, so this looks good. Next, if you give it the correct number of arguments, which is the name of the program, and then the URL, which is vulnerable to command injection, and then the command that you want to run, then what we're going to do is we're going to take in the first argument, which is the URL, and set it to a variable called URL. So sys.argv1, and then we'll take in the second argument, which is the command, and save it in a parameter called command. And then we're going to print exploiting command injection. And we're going to perform the command injection, and we're going to do that by calling a function called run command, and it takes in the URL and the command as input variables. All right, this looks good. Now let's implement our run command function. Again, it takes in the URL and the command variables. And then let's set the stock path. So this is the page that is vulnerable, and we'll take that from over here. So let's copy that and put it in right over here. Next, we're going to construct our command injection string. So again, we said it would be, let's say 1, which is this variable right over here in the product ID field. And then we added the AND character in order to concatenate or chain commands. So let's put a space, and then we add our command right over here, which in this case is the whoami command. If you enter whoami in the command line, if you enter another command, it would be another command. So this looks good. And then we're going to create a params variable, which is the parameters of this request over here. And this request takes in 2 parameters, the product ID parameter. So let's copy that. And let's say 1 over here. And it takes in a second parameter, which is the store ID parameter. So let's copy that and put it in right over here. Okay, so when we first solved the lab, we exploited the product ID field. However, when we outputted the content of the bash script that is vulnerable to command injection, we saw that not only is it the product ID field that is vulnerable, it's also the store ID field. So to switch things up, we're going to be exploiting the store ID field in the script. So in here, we're going to say the content of store ID is going to be command injection, which is this variable right over here. And then we're going to perform the post requests. So we'll say requests.post. And the reason it's a post request is because right over here you could see the request that is vulnerable to command injection is a post request. So the URL is URL plus talk path. And the parameters it takes is params. And then we're going to set verify to false so that it doesn't verify TLS certificates. And we're going to set proxies to proxies. And what that means is anytime this request or this line of code gets run, it gets sent to the proxy first before it gets sent to the application. And again, the reason I do that, and you'll see it's very effective when you start writing your own scripts for web applications, is that it allows me to debug my script in case it's not working properly. And then I need a way to confirm that the script worked. So if you see over here, if we remove this and then we just keep it at 1, hit send, and it timed out. So we're going to have to open up a new one. Let's close this, access the lab, go to proxy. Okay, perfect. It's intercepting the request. Go to view details and then check stock. And let's send this to repeater. Okay, hit send. Perfect. So you could see over here the content length is always 3. When it comes to product ID 1 and store ID 1. So what we're going to do is we're going to use this as a differentiating variable to see if we properly exploited the command injection. Because if we exploit the command injection over here, so if we say and whoami, and then we use the hash sign, and then Control U to URL encode it, hit send, the content length is bigger than 3. And so that's what we're going to use in order to determine if we properly exploited the command injection or not. And the way to do that is we're going to say if the length of the response of the request is bigger than 3, then the chances are we properly exploited the command injection. So we're going to print command injection successful, and we're going to print the response of the command. So we're going to say output of command is r.text, which would be this right over here. Okay, this looks good. And then we're going to say else. So if the content length was 3 or smaller, that means chances are we didn't exploit the command injection. So we're going to say print command injection failed. Okay, let's save this and let's run it. So terminal, new terminal, and then we're going to say Python 3 command injection lab01.py, and we're going to take the URL of the application. So just go to the main page, copy that, paste it, hit send. And it's giving me the usage instructions because I didn't give it the proper parameters. So that's working great. That's good. All right. So the way you run it is you give it the URL of the application and then the command that you want to run. So in this case, I want to run the whoami command. And perfect. So it says exploiting command injection. Command injection was successful, and the output of the command is this right over here. So now the reason it outputted the 62 number is because what we're doing is we're exploiting the store ID. And so this command over here, the original command that was supposed to be performed in the application, runs, and then it runs our whoami command. And so you get the output of both commands, which is fine. All right, so we successfully completed the exercise by exploiting a simple case of a command injection, first manually, and then we scripted the exploit in Python. In the next tab, we'll look at how to exploit a time-based command injection. If you liked the video, hit the subscribe and share button so that the video reaches a wider audience. Also, make sure to check out my course if you're interested in seeing more videos like this one. Thank you and see you in the next video.